Hello, everyone. Welcome to this amazing event we're having tonight, the Astro Artists Club with Science Friday and the Adler Planetarium. My name is Diana Montano, and I am the events producer for Science Friday, and I'm your host for today's live stream where we are going to be looking at nothing else but the sun, a couple other things, but mostly the sun. So welcome, everyone. I saw that we have a lot of people joining us today from, let's see, Burlington, North Carolina. We've got a bunch of people from Chicago. We've got Vermont. We've got 2 people on a cyber date. That's very cool. Northern Nevada, wherever you're joining us from, thank you so much for being here tonight. Again, we're going to have a fantastic night. If you don't know, Science Friday, we are your one-stop shop for all things science news. So we have a radio show that goes on the airwaves every week from on Friday, as you would probably expect, from 2 to 4 p.m. Eastern Time. So you can want to check us out on any of our local radio stations or on our website, sciencefriday.com. It is a great place to start. We also have educational videos. We have lesson plans around STEM and other science-related topics. We have events like this one. We've got digital articles. We've got all kinds of things. So you can find us, again, sciencefriday.com. That's a great place to start. So we are streaming today to YouTube, and if you have questions for any of the experts that are going to be here with us today, feel free to put them right there in the chat. That is going to be the place where you can see all the questions that other people have asked, but also your questions, and they'll be able to see them too. So feel free to put your questions there whenever, and we're going to grab them and ask them at the right time. But don't forget, if you're inspired to make some really great art today, that is a great thing to do. You can post your in-progress photos or notes on social media. Make sure to tag SciFri at SciFri and at Adler Planet for the Adler Planetarium, and use the hashtag #lookup. That'll help us find your image. And we're going to share some of those images throughout the live stream. So you might see your artwork front and center as part of our live stream. But if not, you can go online later and look at all the amazing, cool artworks that people have been making throughout the night. And if you like what we're doing and you're able to contribute, consider making a donation so we can bring you more really cool stuff like this. You can give $3.65 because it takes 365 days for the Earth to orbit the sun, or $8 because it takes 8 minutes for light from the sun to reach the Earth. Whatever you can give, any amount really helps us make this programming happen. Proceeds will be split between Science Friday and the Adler Planetarium that are given today. So you can find a link for donations in the YouTube description below and in our chat. And seriously, thank you so much to anyone who can give. But really, just thank you so much for being here. We're really stoked that you're all here. So besides your questions, make sure you get in that chat and you tell us where you're joining from today. And I want to know, when you've been looking up lately, what are you seeing? Do you get to step outside and look up at the day sky or the night sky? Or maybe you're just looking through your windows. I want to know sort of what you're seeing. So let us know in the chat. Okay, but it's not just me today. No. In the chat, we have Colleen from the Adler Planetarium and Kyle Marion from Science Friday. They're helping us moderate, so if you have questions, feel free to put them in there. But I want to, without further ado, welcome our co-host for today, a very important person. She is the Director of Public Observing at Adler Planetarium, and she is the one with the telescope over in Chicago. So please welcome Michelle Nichols. Hey, Michelle.
Hi, Diana. Hi, everybody. It's so great to see so many people on with us today. We're so excited. Thank you for joining us.
Yes, thank you so much. Michelle, I'm so excited that you are here. All right, so we're not just here because the Adler and Science Friday really like each other, which is also true. We are here.
It is true.
Yeah, we are here because it is the Adler Planetarium's 90th anniversary. Can you tell us a little bit about what you guys are doing to celebrate, besides being here with us and looking at the sun today?
Well, what more could we do than be with Science Friday? But we do have a few more things going on. So we just debuted a new Google Arts and Culture exhibit called 90 Years of Stellar Connections. And so if you go to the Google Arts and Culture page, just search for Adler Planetarium, and you will see that one plus all the others that we have up already. We have an online collage filled with photos that our followers and fans have sent to us, put into our logo. So you'll see that on our website. If it's not there yet, it will be there soon. But we're doing this event and enjoying the sun. We're just really happy that so many people could join us today and consider creating some artwork to represent how they see the sun.
Totally. And I'm so excited. I mean, I think I'm really excited to see the sun. The telescope is incredibly cool. But not just that, I want to be able to see people's interpretations of what they're seeing. It is the coolest thing when people can sort of take art and science and make it their own. So totally agree. I'm very excited. Amazing. So I think this is actually a perfect time. Speaking of some of the other ways we're going to be celebrating tonight. So we have, if you signed up for our RSVP a few days in advance, you'll see that I sent you an email that had a recipe for a drink that you could make for tonight's celebration. So if you were able to make that drink in advance, fantastic. I had two versions of the recipe in the email. There was both an adult drink, but there was also an all ages version of the drink. So whichever one you are able to make, and if you're able to make it with us here right now, we actually have a video of a mixologist from Chicago. He was going to show us how to make the cocktail. So we're going to bring that up. Hold on for just 1 second.
What's up, everybody? Welcome to the Astro Artists Club's Cocktail Corner. My name is Joe. I'm a longtime local bartender here in Chicago, as well as a cocktail enthusiast. And today, we're here at my home bar, because it's quarantine, to kick off this party with a cocktail called the South Side. Now, important note before we go into some history is that we're doing two versions of this cocktail. We're doing the traditional with gin, as well as a non-alcoholic version with seltzer. There's a couple of ideas how this cocktail came about. First, in Prohibition in Chicago in the 1920s, some entrepreneurial gangsters decided that they wanted to add some lime juice, maybe some sugar, some mint into their less than legal wares that they were applying to make it more palatable for folks just looking to get some drinks. From there, it moved to the East Coast where it became extremely popular. The other one in theory is in the South Side. Sportsman's Club in New York made a version of this cocktail. Once again, this is a delicious cocktail, so everyone loved it, and from there, it's sort of like a wildfire across the Gold Coast. Personally, I like the Chicago version. I like to think that we have some entrepreneurial gangsters on the South Side really just pushing the envelope in the 1920s. But whichever one you subscribe to, it's up to you. I'm just excited to make this cocktail for you guys. So what you're gonna need is anything you can shake the cocktail in. I have a shaker tin right here. Ice. You can use anything else that measures liquid as well. Cocktail glass of your choice. A strainer. Lime juice, or you could use lemon juice if you have that on hand. Simple syrup. Mint, preferably fresh. Gin. I'm using a Geneva gin from Quincy Street Distilling here in Chicago today. It's a personal favorite, but you can use whichever one you like. And we're going to seltzer if you're doing a non-alcoholic version of the drink. All right, let's make this cocktail. We're going to start with our shaker tin, and we're going to measure out 2 ounces of gin into it. Next, we're going to do 1 ounce of simple syrup. Important note, you can buy your simple syrup, but I prefer to make it at home. This is 1 cup of water with 1 cup of sugar, and just made on the stovetop until it's well combined. Next, we'll be adding lime juice, and 1 ounce of that as well. Alright, we're going to get our ice ready in the other half of the chicken. And at this point, we're going to add a sprig of fresh mint in here. We really want to kind of infuse that mint flavor. It really helps the drink. And since we are starting off the party, and we want to bring the party, I'm going to do a little dance while I shake, just to have some fun. You really want to make sure you do a vigorous shake on this. It really helps to get that mint in there, which we're really looking for. There we go. And we're going to take our glass of choice. Personally, I like serving this in an antique coupe glass. It was a gift from my grandmother. Thank you, Betty. Now, if we were going to do the non-alcoholic version of this drink, you would just take your lime juice, your simple syrup, and your mint and put that into a glass. And then add the seltzer right on top and stir. You don't want to mix this in a shaker with seltzer because it'll explode on you. And that's not fun for anybody. All right, so our drink is almost ready. We're just gonna do a garnish of some fresh mint. Give it a slap to get those aromatics going. And place right on top. And that's it. That's the south side. Cheers, everybody, and enjoy the party.
Amazing. Well, thanks to Joe for that. That was fantastic. I actually tested out this drink earlier yesterday. It is a tasty one. So it was great with just seltzer. It was great with making it as a cocktail. So whatever you got in hand, if you want to join us in raising a glass, whatever it is, if it is our signature drink for tonight, if it is a glass of milk, if it's a glass of water like I've got here with me tonight, please let's raise a glass for the 90th anniversary. Cheers. Cheers to the Adler. I know some people say that it is not good luck to cheers with water, but I think it's a good luck all around. So I'm not too worried about it. But all right, Michelle, it is not just you and me though up here. We got to look at the sun, right? Let's get to looking at that beautiful sun of ours, that closest star. So right now, I am going to welcome our next guest to the live stream. His name is Mark Subaru. He is an astronomer and the director of Space Visualization Laboratory at the Adler Planetarium. His research is focused on all things space, but especially the structure of the universe itself. Very cool. Mark, I'm going to bring you up right now. Hey, how's it going, Mark?
Hi, it's going great. I'm so glad to be here.
Thank you so much for joining us. And so what else is joining us but, this way, it's in this direction, the sun. Look at that beautiful sun. So Michelle, can you tell us a little bit about what exactly are we looking at here? Obviously it's our sun, but what can we sort of look out for?
Absolutely. So this is a video that I took about a week and a half ago of the sun. We took video in advance because those of you in Chicago, and I know there's a bunch of you on right now, you know you can never totally rely on the sun to actually do what you want it to do because there's usually clouds in the way. But
exactly.
We have the sun. Yeah, exactly. If you don't like Chicago's weather, wait 5 minutes. But if you take a look at the video, you'll see this is a special view of the sun. It's taken through a special telescope that looks at a very particular type of light that the sun puts out. And you'll see little bits coming out of part of the side of the sun. We call those prominences. And a prominence is just a bit of the sun's material coming off the side. And sometimes you see it as a loop. Sometimes you see it as just like a little finger. You'll see me moving the telescope from time to time. So if you see the sun move in the image, that's me. Doing that when I recorded this. So I recorded this on May 1st. And so, yeah, just check that out. It just looks so cool. I never get tired of looking at that video.
It really is beautiful. I mean, the thing I didn't quite expect was also how it's really yellow in the middle. And then as you sort of grow out, it gets a little bit more orange. And at the very edge, it's this like really, really beautiful, deep orangey red color. It's like,
yeah. So that's you could say it's kind of real. So as you look toward the edge of the sun, you're looking toward a higher altitude than you are at the middle. And so the middle is going to show up a little brighter. The edge is going to show up a little dimmer. And we have a fancy term for that in astronomy. We call it limb, as in L-I-M-B, limb darkening. And so you can see that in the image. And so that's why it'll appear a little brighter orange, and a little darker orange near the edges. I also adjusted the color a little bit. This particular wavelength is normally kind of a red pink color, but that wasn't showing up great on my screen, so I adjusted the color a little bit. So this isn't quite the color of the wavelength that you might see through the telescope, but trust me, it looks a lot better than it did when I left it the regular way.
Very cool. So, by the way, if you are just joining us, I'm Diana Montano, and this is Astro Artists Club with Science Friday and the Adler Planetarium. I'm here with Mark Subaru, who we just introduced, and Michelle Nichols, who is the Director of Public Observing at the Adler. Mark, actually, right behind you, you've got this virtual background. We can't zoom in too much, but can you tell us a little bit about what's going on right behind you?
Sure. Well, this is an image taken this year by a new telescope on the island of Maui in Hawaii.
Hmm.
And it's state-of-the-art solar telescope. And this is actually the highest resolution photo of the sun ever taken. It's the most detail we've ever gotten in the image of the sun. And what you're seeing with all that structure is what we call solar granulation. At the top level of the sun, that's where heat's transferred from the core to the surface, and that material goes up and down, and that's what you're seeing there, all these little regions where material is flowing up and down in the sun.
Very cool. That's really neat. Yeah, I kind of wish we could zoom in a little bit more to see some of that detail, but that's very cool. I mean, I'm going to actually direct our attention right back to the sun that's just moving around a little bit in our telescope right now.
Yep.
So, Michelle, are we seeing the things that we're seeing on the edge there? Those are the sort of solar flares. Is that also the light spots that you're seeing in sort of the top right corner?
Well, it's those areas, those lighter spots. Oh, and just on cue, there they are. Yeah, those lighter spots are areas of a little bit more magnetic activity on the sun. So they show up a little bit brighter in this particular image. And the parts on the edge, they're the prominences. That's different from a flare. A flare is a quick release,
The light
a release
spots
of
that you're
energy,
seeing in sort of the
and a
top right
prominence
corner?
is just kind of a gentle looping structure that lasts for a few hours or so, and you can see those change. So those magnetic activity areas are areas where you might see some prominences later. So the sun rotates, and so a few days later, those areas might appear on the edge, and you might get to see a prominence in that spot. So it's kind of fun to watch the sun from day to day to see how it might change.
Very cool. Very cool. Just so everyone knows, I see your comments. Thank you so much about some of the volume issues we're having. So if you haven't already, my friends in Zoom, if you wouldn't mind turning up your volumes a little bit, I'm going to try and turn mine down just a bit so that everyone, I'm going to try my best also not to get too excited about things because that will also make it so that you can all adjust your levels a little bit. But actually, I want to move to some of the questions some of our audience members have. So Benjamin asks about the miasma of incandescent plasma. Ooh, it's definitely a rhyme. I'd love to hear more about that a little bit.
Mark, do you want that one?
No, you can probably count this better than I can. So,
Yeah, the miasma of incandescent plasma, if I'm not mistaken, is from a They Might Be Giants song, I think that's where that comes from. So, yeah. Thank you.
The answer is yes. Yes, it is.
Yes, it is. We love bringing in the rest of the arts into this evening as well. So song, dance, video, artwork, no problem. So yes, the sun is a large ball of hot gas that is called a plasma, and so it's you can imagine hot. This is hotter than hot. This is incredibly hot stuff. So the surface temperature where you're looking on the sun, the surface temperature in this image is over 10,000 degrees. So pretty hot stuff.
So, we've got another question from Joe who asks, how tall can a prominence be? I'm very interested in this. How tall do we think?
Yeah, so you saw the prominences earlier, those little bits off to the side. Those were slightly bigger than the Earth.
Whoa, what?
Yeah, the Earth could fit underneath those. So I'm seeing them back on mine. I think they might be back for you too. So yeah, the Earth could easily fit, the one that's on the left, the Earth could easily fit underneath that one.
That's
yeah. It's
amazing.
Surprisingly, you don't think about how big the sun actually is. So if you had a hollow sun and filled it with Earth marbles, you'd put in 1,000,000 Earth marbles. And you can fit 109 Earth marbles across the middle. So our sun is enormous compared to us.
Yeah. Some would, I mean, if I didn't think so before, I definitely think so now. That is so cool. Mark, can you tell us a little bit about? Your job is in the visualizations department at the Adler.
Yeah.
Can you tell us a little bit about what that is? What does that mean?
Well, one of the things about astronomy is everything we study is super far away. The sun's actually one of the closest things. We can send spacecraft to the sun and actually kind of sample the sun. But for the most part, the things we study are so far away we can never actually go there. So finding ways of taking data of remote sensing, really remote sensing the universe, and making pictures out of that, that's what we do. So it might be things in our solar system like this, imaging, but it might be mapping galaxies at the edge of the universe and building 3D maps of the universe.
Very cool. We're actually going to take a quick break from our telescope image and take a look at one of the visualizations that Mark was just talking about. So this is a solar prominence from May 5th of this year. Mark, can you tell us a little bit about what's going on here?
Yeah, well, you're seeing actually some of the same things we saw in Michelle's video, but this is a close-up. It was taken by a planetarium colleague of ours, Martin Ratcliffe, and this is a time-lapse spanning 30 minutes. So you'll see it loop a few times as we play it. And here you can really see some of the stuff Michelle was talking about, how it's really magnetic fields that drive all the activity on the sun. And you see material being launched off the surface of the sun and coming back down in these loops that form the prominences. And I think it's pretty spectacular. This is taken from his backyard in Kansas, right? That you can get this level of detail just from your home.
That's amazing. Do you know, is this a telescope that someone could get on the internet, or is this a quote unquote professional telescope?
Yeah, well, it might be what you call prosumer, but it's a very similar. It's actually pretty much the same telescope as Michelle has there. She can probably hold it up. Perhaps a slightly larger version.
Oh, very cool. Michelle, I'm going to come back to you so you can show us that that telescope a little bit later. But right now, I actually want to introduce another guest, our last guest that is going to be joining us in the live stream today. So please wave hello to Pedro Raposo. He is the Director of Collections at the Adler. He's in charge of how the public, like us, uses the Adler collection of historic scientific instruments, rare books, and works on paper, either through their research, online exhibitions, or events like this one. Thank you so much for being here, Pedro. Can you tell us, how are you celebrating the 90th anniversary of Adler Planetarium opening?
Yeah, so of course we take care of our archives and our collections, and we, the collections department, work on that exhibition on Google Arts and Culture that Michelle mentioned. And of course, having a strong history bent, we always like to look back as we look forward and see our institution has been engaging people with astronomy and space science over the decades.
Very cool. All right, so I'm going to bring up some of the collection images that you chose for us today. So we're going to actually start with this image, what it looks like, two people here sort of in a workshop, I guess. Can you tell us what's going on in this one?
Yeah, it's kind of an early solar observatory. So what's going on there is that, so you see the guy on the right is Christoph Scheiner. He was a Jesuit German mathematician and scholar, and he got really interested in sunspots. So there were accounts about sunspots since antiquity, but with the rise of the telescope, that was around 1608, and this image is from a book published in 1629, so the telescope was still a recent invention. So Galileo, Scheiner, and others start observing sunspots. And so Scheiner got really interested in them. And he actually developed a method and an apparatus so that he could keep track of sunspots. And now perhaps we can zoom in a little bit, and we will see Scheiner's assistant. And what he's doing, he's projecting the image of the sun using a telescope. So he's not looking directly. So they were smart enough not to look directly at the sun. Mm-hmm. They were projecting the image of the sun. And you see the image of the sun projected onto a kind of a screen. That's a sheet of paper. And so they can draw the sunspots and keep track of them over time. So Scheiner got really interested into this topic. But he got into a bit of dispute with Galileo. And why was that? So Galileo, as soon as he observed sunspots, he said, well, these spots belong to the sun. And Scheiner initially said, no, they must be some kind of satellites. And why was that? Why was it such an important question that the sun could have spots? Well, maybe we can move to our next image. And what we'll see, it's a beautiful print from 1660 from a book called Harmonia Macrocosmica, which is, I would say, it's one of the most beautiful astronomy books ever published. So what you see there, you might see two men on the lower side of the image. So the man on the right is Copernicus, who in the 16th century posited that, well, maybe the Earth orbits the sun just like the other planets. And this might sound trivial today, but it was not in the 17th century. Most people believed this, that the Earth is at the center of the universe, and everything, including the sun, revolves around the Earth. And importantly, things in the heavens are completely different from things on Earth. The heavens were supposed to be perfect and immutable. So even nowadays, when we say, oh, I feel so good, for example, I feel so good now to be here with you. I'm in heaven, this is heaven. That's a reminiscence of that old idea. So what these people were learning at this time was that, well, after all, the heavens are not perfect and immutable. The heavens can have change, the heavens can have all sorts of phenomena, and so they are actually interesting. And our own Earth is part of the heavens as well. So abandoning this idea that the Earth is totally different from the heavens, this was extremely important. And let's move to our next image, where we'll see a direct application of this new mindset. So what we see in that image, you see a name. So that's the theory of the sun, of how the sun works, so to speak, according to Athanasius Kircher. Kircher was also a German Jesuit, and he was an absolutely fascinating figure. So basically, he wrote about every single possible subject that you could write about and investigate in the 17th century, and that included geology as well. So he was very interested in geological phenomena, like volcanoes and earthquakes, etc. And he is said to have actually gone down into the crater of the Vesuvius after an eruption, because he wanted to understand how a volcanic eruption happens. So basically, he developed this idea about the Earth, that the Earth has fires inside, and those fires actually cause geological phenomena, like volcanoes, earthquakes, etc. So what he did, because he was no longer thinking that the heavens must be totally different from the Earth, he applied these ideas to the sun. So what you see in that image, basically, that's the sun, even though it looks like some kind of terrestrial landscape.
It totally does, yeah.
Smoke, and there are eruptions all over and all that. So basically, he explained, okay, sunspots are the result of volcanic eruptions in the sun. Of course, now with hindsight, all of this sounds bizarre and wrong, and it is. But for the time, actually, it was daring for Kircher to try to explain how the sun works, making analogies with what we had learned about the Earth. It was only in the 19th century, actually, that we started to have tools to actually delve into what the sun is made of, and how the sun works. So we can move to our next image, and that will look like a sort of a barcode. So that's actually the spectrum of the sun. So that was published around 1817 by a German astronomer and telescope maker called Josef Fraunhofer. So Fraunhofer was trying to improve the lenses of telescopes, and he was experimenting with prisms, and he used a device that nowadays we call a spectroscope to actually disperse the light of the sun. So what you get the different colors that form the light of the sun. You can't see the colors in this particular image, but basically imagine the colors there. And then he was not the first to see that, but he realized there are these vertical lines all over the spectrum. And so what he did, he observed those lines in great detail, and he created this very accurate map of those lines. So he basically used that to improve his telescope lenses. He didn't go into details what causes these lines. He didn't go into that. But 3 decades later, other scientists realized that these lines correspond to specific chemical elements. And so now, if you can relate the lines you see in the spectrum of the sun and the stars with particular chemical elements, now you can answer the question, what is the sun made of? And this is the beginning of modern astrophysics. So throughout the 19th century, you have people who start dedicating themselves to solar science. which becomes to a great extent a field in itself. And one of them was actually our first director of the Adler, the astronomer Philip Fox. And now we can move to my last image. So here we'll see Fox on the left, and so he has this cohort of other astronomers. That's on the terrace of the Adler. And so the device you see there, that's actually a solar telescope. I want to call out, there's only one woman in the image. That's the astronomer Annie Jump Cannon, worked in Harvard, and she gave extremely important contributions to the development of stellar physics. So I wanted to finish with this image because I find it very interesting that since the beginning, Adler had a telescope to observe the sun. This was meant to be a research tool, but it became more of a tool to actually project the image of the sun. So the telescope extended through the lower gallery of the Adler. And so the spectrum of the sun and an image of the sun could be shown to visitors. So this is pretty much what Michelle Nichols is doing nowadays with a smaller telescope and by other means. And one of the things that fascinates me about the Adler, and going back to your questions as we celebrate our 90th anniversary, is that many people think that planetariums are about replacing the real sun with an artificial, the real sky and the sun with an artificial sky. Actually, planetariums have always been, and the Adler for sure, has always been a place where we invite people to actually explore the real one.
That is so cool. This last image is so amazing. I can't even imagine. This is on top of the actual planetarium, is that right?
Yes, that's correct. Yeah. So it's just by the dome. And actually, this telescope worked, I believe, well into the early 90s, maybe. And eventually it was its math. I mean, I think now it's just much easier, for example, to have a telescope like Michelle's and, set up your telescope when you want to share the sun with other people.
Yeah, no, that makes sense, but that's very cool. Well, Pedro, thank you so much for joining us and showing us some of these amazing videos. So there is an exhibition that you want to point people towards. Can you tell us a little bit about that before we bid you adieu?
Okay. So we have this exhibition, which Michelle already mentioned. So it's 90 years of stellar connections. I just wanted to say briefly how we try to celebrate the 9 decades of existence of the Adler in that exhibition. So normally when you have an anniversary, you will tend to think about, first director and then the building, and then we expanded the building, etc. And what we mean by stellar connections is that we wanted to focus on how the Adler, through its sky shows, observing programs, etc., has been engaging people with astronomy and space science and actually bringing people together. So it's all about the people, and not only the people at the Adler, but all the people that have been brought together by the programs we have and the things we have at the Adler.
Amazing.
So I hope everyone will check out the exhibition.
Yeah, I hope so too. We're going to post a link.
Culture.
Yeah, we're going to post a link to that in the chat, but also you can find it on Adler's website as part of their 90th anniversary. Thank you so much, Pedro. It's been so nice to have you here. We're going to take actually a quick break away from some of the more visual stuff here that the Adler has, and we're going to instead look at some of the artworks that you have made. So we have been checking out some of the things that you have been making online, and so some people have been posting the artworks that they have been making either during this event or before this event with the hashtag #lookup. And that is how we are finding some of these images. I mean, look at this. Ava H6 has made this amazing solar system. I love it so much. The sun is almost like exactly how we've been talking about it today. It's got that sort of different color on the outside with the other color on the inside. So very cool. Amazing. Oh, and then we've got this other artist, Ben H4, has made a tile sun. Oh, this is so cool. I love this because it is, not just the traditional art making supplies that we think of when we think of art. It is these tiles, these tessellation tiles. That is so very cool. Ben, thank you so much for making this artwork. I have one more to share here with you. Scribble Sun. Reese H2 has made this amazing Scribble Sun. My Adler team, what do you think?
I think we have some awesome artists in our audience right now. Those are so adorable. Oh my goodness. Such good stuff.
Yeah, fantastic. Scribble Sun. What a great name, too.
I agree.
When I think about some stuff we were seeing with the prominences, it's kind of scribbly anyway when the sun gets going.
Oh my goodness. Yeah, very scribbly. Yes. And if you see them move over time, they loop and twist, and it looks like what I might do if I might draw that. I might make loops and scribbles and all of that. So yeah, totally appropriate. So.
I'll just add that it's fascinating to see this and to see this happening today as we have this this show, because when you work with collections in the history of astronomy, we realize that art has always been so important for the development of astronomy. And I think you actually get that from some of the images I showed. some of these images are, or maybe all of them, not so much the photograph, but all of the others, to varying degree, they're all works of art and science.
Mm-hmm. I would hope that maybe one day we will see Ava's or Ben's, or maybe we'll even see Reese's artworks in the Adler's collection. That would be the cherry on top of the sundae, I think. All right.
Exactly.
Well,
we do have works in our collections that are not primarily scientific works, but are actual works of art. So we also collect that.
Very cool. Amazing. All right. Well, thank you all so much for sci-arting with us. Again, that hashtag is #lookup. So if you want to post some of the art that you are making, share with us online, we would absolutely love that. All right. I'm going to switch over. We've got another video of the sun here through a telescope. Hi, Michelle and Mark. You're back online with us. And if you're just joining us, my name is Diana, and I am the events producer for Science Friday, and this is Astro Artists Club with Science Friday and the Adler Planetarium. We just spoke with Pedro Raposo, who is the curator for the Adler's collection, but now we are back looking at our telescope at the sun with Mark Subaru, who is an astronomer and the director of Space Visualization Laboratory, and Michelle Nichols, who is the director of public observing at the Adler Planetarium. All right, I want to get to some more questions from our audience because they have some really great questions, but I want to really quickly mention that really cool prominence that we are seeing the top left there. That's very cool.
So what's really great is the video, the visualization that Mark showed earlier on May 5th. One of the days of the video that we have in here is May 5th. So we have a prominence which looks, it blew my mind when I saw this, because the sun has been so inactive lately, and we're in the depths of solar minimum right now, and what that means is not much going on. And I happened to catch video of the sun during this particularly amazing week, and it's back to being kind of boring right now. So the sun is back to being solar minimum sun, just like normal. So I'm just blown away by what I was able to get with the telescope. Diana, are they able to see me at all?
Yeah, absolutely.
Yeah.
You want to show us the telescope?
I want to show them the telescope. So this is it. So this is the telescope that I use, and it's not terribly big. It looks at a particular wavelength of visible light, meaning light that your eyes can detect. It blocks out all the others and just lets that one wavelength through. And that's what we're getting in these images. And that's where these prominences and other things show up really, really well. So yeah, somebody had asked, I want to make sure I get the person's name. Give me a sec. It was Benjamin. Benjamin asked, can the Adler telescope detect light that your eyes can't see? And the answer is no. So it's only light that your eyes can see. So that's what makes this extra special, is your eyes are detectors, just like these telescopes are. Just don't go look at the sun. Please don't look at the sun.
Yes, we have very special, if not, stuff you can get yourself as well. This isn't something that just the Adler has access to, but we are using equipment. Actually,
correct.
Carolyn has a question, which is what instruments are used to measure the sun's activities? Besides a telescope, is there any other instruments that we use today?
Oh yes, and Mark, if you want to jump in as well, there's a lot of spacecraft. You want to take this one?
Yeah. So I mean, the sun, there's several fleet of spacecraft measuring the sun right now. One notable one is the Soi Dynamics Observatory, which takes like 4K TV, essentially video of the sun, You can actually go online and watch that all the time in many, many different wavelengths. And typically this is working in wavelengths of light we can't see, in the X-rays and in the sort of ultraviolet region of the spectrum. And that, because the sun's so hot, some of the material is so hot, we actually look at very energetic wavelengths of light to see that. And when you look in those wavelengths, you'll actually see much more activity than we see through visible light. Another thing you can do is, the sun isn't just that ball. It actually continues an atmosphere that continues way beyond the surface.
Oh.
What we call its corona. And you can view that as well by what spacecrafts do is they'll actually block out the center light from the sun so we can see that faint light coming from around the sun. And that's where we see things like what are called coronal mass ejections. These are events where material is launched off, in some cases, billions of tons of material are launched off, traveling at millions of miles per hour. And and when it's headed towards us, they can actually cause a problem.
Yeah.
With,
So
satellites and
those
weather.
are called coronal mass ejections, right? So it's coronal, like the corona, that big atmosphere layer. Mass, really big. Ejections, stuff that flies off, right?
Yep.
Very cool.
So the spacecraft allows us to see this. Normally we can't see it, but there's one very special time when you can observe the sun's corona with your own eyes, and that's during a total solar eclipse.
Oh, that is so cool. I have a lot of hopes to see another one of those in my lifetime. It's very cool. Okay.
Oh, you will. You will. April 8th, 2024. That's the next one. So
That's
mark
right.
the calendar.
Yeah.
It's a Monday.
It's going to move sort of through the United States from Texas to Maine. Is that right?
Correct. Yes, it's going to come up through Mexico, and it's going to pass over some larger cities this time than the one did in 2017. So you'll get, I believe, Dallas and I think Austin, if I'm not mistaken, and Cleveland, Indianapolis.
Oh, cool.
So Chicago, from the Chicago area, it's going to be about 94% of the sun will be covered, which means 6% of the sun will be visible. So that means don't look at it. But if you're within that path, it's going to go up from, like you said, from Texas up through from the southwest to the northeast.
Very cool.
And kind of up the St. Lawrence Seaway almost. So
cool.
Yeah, it is April, so kind of iffy on the weather, but
yeah, we'll have to see.
we'll see.
Very
It's
cool.
going to happen no matter if we can see it or not.
That's a good point. Yeah. I have another question here that I really love, and actually I am wondering too, because I don't know the answer. Does the sun have seasons per se? That's a question from Trevor.
Wow, that's an interesting way of putting it. It has cycles, and what that means is there are periods of time when the sun is particularly active, when you get a lot of sunspots, you get a lot of flares, you get a lot of prominences, and a lot of coronal mass ejections. And then we have a period of time when there's a lull, when you get not so much of any of that. The period of time is between 9 and 14 years from peak to peak or low to low.
Wow.
So yeah, it's not exactly seasons, but it's definitely a cycle. If you think of seasons as cycles, yes. And so we are in the lull right now. So that's why I was doubly happy, triply happy that I got the week of video that we did.
Would you say that like in about 5, if it's about 9 to 14 years, the cycle, does that mean around like 6 or 7 years from now it'll be high time?
So we're near the end of solar minimum. We're kind of in the depths of it right now. So solar maximum, which is what we call the peak, will be somewhere between 2023 and 2026.
Fantastic.
So somewhere in that range. So you'll see more sunspots, more prominences, more flares. So
very cool. I have another question from A&N Productions, who asked, what happens when objects come close to the sun? I guess we can talk a little bit about what close means, but Mark, what happens? Let's say something gets really close to the sun, or maybe the sun gets really close to it. What happens?
Well, it's not good, right? It's difficult to get too close to the sun just because it's so hot. We've actually launched a new spacecraft to study the sun called the Parker probe, which is going to travel close. Oh, it's already traveled closer to the sun than any spacecraft before. One of the things that we're going to talk about a little bit is what happens in the future. So if we wait a long enough time, the sun's going to come to us. Our sun is changing over very slow periods of time, but in billions of years, it's going to actually grow. It's going to become a red giant, and the surface of the sun will essentially be almost out where we are now. So we're going to find out directly what happens when the sun gets close to us, but it's not a good environment for life, that's for sure.
Yeah, I bet. Actually, that is a great transition, Mark. I'm going to start playing the second visualization that you showed us. So can you tell us a little bit more about what is happening here? We're kind of seeing the future of the sun.
That's right. So what we're showing is an interactive. So you can actually, we'll share a link with you and you can go online and you can play with this yourself. But this is a simulation of the future of our solar system run by my colleague at the Adler, Aaron Geller. And what you're going to see is the stages that the sun goes through. So you'll see the solar system, the orbits of the planets, Mercury, Venus, the Earth, Mars. And you'll see the sun transition from its current state to its red giant state. You'll see it swallow Mercury and actually suck in Venus.
Oh, that's what those little rings are, right? That's the orbits?
It's the orbits of each of the planets. That green bar that we're watching is what we call the habitable zone. So that's really where you want to be for it to be comfortable for life. And you'll see as the sun warms, that habitable zone goes out into the outer solar system.
Yeah, and it's starting to flicker a little bit as the sun is flickering too.
Yeah, so it can be a little bit misleading when you watch this because we're condensing billions of years into a few seconds. So it looks like the sun's doing this. It's actually over a very slow time. We actually play this two different ways. The first way, we messed with time, and we did that to show you all the different stages of the sun. The second time it plays through, it'll be uniform in time. And what you'll see is they're very slow stages where the sun's very constant, and then the changes happen very rapidly, which is why we expanded them. But the sun will go, it'll slowly warm over the next billion years. In about a billion years, we may have to go to Mars. And then in about 4 or 5 billion years, it'll start to enter more like 5 to 6, its red giant phase. And that's when it might be nice to find another solar system.
Yeah, that sounds like a good move. Amazing. Well, we're going to drop a link to this so that you can check it out yourself as well in the chat. So feel free to look for a link there. I want to thank all of my experts, Mark, Subaru, Michelle Nichols, and Pedro Raposo, who was our collections expert. Please, in the chats, give them a round of applause. They have given so much time and attention to all the work that they do, but especially this event, and wish the whole Adler Planetarium team a happy 90th anniversary. So if you still have a drink, I'm going to cheers one last time to the Adler. Thank you so much for being here. So before we actually say goodbye for real, we have one thing that we want to sort of leave you with. So we want to sort of start and end this live stream with a little bit of art. So we have seen some of the artworks that you have done. I hope that you are still making artworks where you are. And before we go, though, okay, so we started with art. We want to end with a quick poem, but before we do that, I want to remind you that if you like what we're doing here, if you have a little bit that you're able to contribute, you can consider making a donation so that we can keep doing this kind of stuff. The Adler and I had so much fun making this event for you, and we want to do it again. Any amount will help, and so we're going to drop that link in the chat, but it's also in our event description. So thank you to everyone who can give. Again, those proceeds are going to be split between Science Friday and the Adler Planetarium, so we can support both organizations. And thank you again so much for everyone just being here. But again, before we go, we are going to take one last look at the sun as Michelle reads us a poem by Emily Dickinson. It is called I'll Tell You How the Sun Rose. So whenever you are ready, Michelle, we're ready.
All right, and I've got it over here, so I'm going to look off to the side on the camera here. And I'll tell you how the sun rose by Emily Dickinson. I'll tell you how the sun rose, a ribbon at a time. The steeples swam in amethyst. The news like squirrels ran. The hills untied their bonnets. The bobolinks begun. Then I said softly to myself, that must have been the sun. But how he set, I know not. There seemed a purple stile that little yellow boys and girls were climbing all the while, till when they reached the other side, a dominier in gray put gently up the evening bars and led the flock away.
Amazing. Thank you so much, Michelle. This was so much fun. I hope everyone in our chat and watching right now also had a great time with us. Happy 90th anniversary. Please wish the entire Adler Planetarium team a happy anniversary from all of us. And have a wonderful evening. We're going to leave the sun up for just a little bit, and we're going to say goodbye. Thank you all so much for joining us. We'll see you again
Bye,
soon.
everybody.